Assalamualaikum warahmatullahi wabarakatuh and very good morning. Um, Today we are going to have an online class because we have some problem in our lecture room. There is projector problem and also the weather condition is not that good. So I would like to apologize to you all that I have to make a video for online class so that you can watch the video at any time, but it is recommended to watch the video during the class 12 to 2 o'clock. Before I continue to chapter 5, our lecture, to continue the last lecture that we stopped, just to inform you that your assessment marks has been released, where you can see in ecom for the assignment, quiz, and also test. Those who are missing some assessment, you focus on the next assessment. This is to give you experience that when you are given a task, please be respect to the due date, because later on you will face a lot of pressure to submit assignment while you are working in real world later on. So do not message me to open back the previous quiz, just focus on the next assessment. For the test one, some of you asking the marking scheme. I would like to explain to you here today, before we start the class. Let do some revision on the test one, so that you can see your performance, or you can check your um, your answer later on. I will distribute to you when we have a physical class later on. Okay. So allow me to share with you the marking scheme. I don't have a specific marking scheme. I mean, because the question, if you look at the question, it is more to the open-ended. It is based on your creativity to answer the question. If your answer is within the scope, so you will get marks. If your answer out of scope, it shows that you don't understand, or you are not able to answer completely, then you will not get a full marks. Right? Let me share with you the. Let me check first. Let me open the marking scheme. Let me explain. I mean, it's not a marking scheme, but I would like to share with you the question. Then we will go one by one to each question, and I will explain how the marking scheme. I mean, not the exact marking scheme, but um, how I marks the questions. I mean, the answer. Okay. Let me open this question so that we can refer to the question, final exam test question. Okay, here is final exam test question. Let me share. Itu final exam test question. Hopefully you can see. So this is the final exam test question. Oh, not this one. This is not the. This is not. Stop sharing. Not that. The test question here. Share. Test question. Okay. Hopefully you can see. So 2 hours, one and a half hours. Okay, let's look at the question one. Question one, how I give the marks to the question one. Okay, here is the question one. Explain how computer vision play a role in health and safety. So this is the assignment. Those who are doing assignment, you still remember the answer. At least you got the point. Then I believe you can answer this question very well. So the marks is given based on you are given the example safety and health in construction, for example. This is similar, the same question in assignment. Okay, computer vision can detect signs of bad behavior of the workers if worker did not wear a proper safety equipment like helmet, mask. Computer vision will detect. So you just explain how computer vision play a roles or how computer vision can automatically detect any safety safety um, safety situation in the working area, in the working confinement. So you will get 5 marks. If your answer like you don't give example, how the computer vision can replace human in particularly in safety and health, then you will not get full marks. Okay. Next, to benefit in medical application. In medical application, what is the benefit of machine vision? A lot of benefits. So you just relate with the medical application. So the benefit like quality assurance, increased productivity, but you have to relate with medical application. Just name what is the medical application and the benefit of computer vision to the medical application. Okay. Name 3 common digital image format. I don't accept the format like .jpg, .pmp. That is not the format that we teach in the class, right? So you can refer to the slide. Question number 2, image histogram. Sketch histogram of a grayscale. You can see the image consists of black and white. All right, so I'm expecting your answer of histogram is throughout from 0 to 255, and the frequency, you just draw the frequency. Normally, you will have a lot of frequency at the high level and a lot of frequency at the low level, because you can see there are two obvious black and white, right? Then you have a middle low frequency at the middle of grayscale. So you just catch and then explain. But if you are wrongly, some of the answer not even sketch the correct histogram, the graph of histogram. Right? Then it shows that you are not you don't remember, or you are not refer to this, you not do the revision based on the slide, so you will not get the marks. Number 2, discuss histogram. So you can discuss the distribution. It's a lot at low level, a few at the middle, a lot at a high level, because based on the image. it has white and black. Histogram equalization, you understand the meaning of histogram equalization. It is stretching out the grayscale pixel values throughout the pixel axis with the same frequency. So everything is in the slide, but the most important is to understand the point. I always remind this one. If you follow my lecture carefully, you take note in my class, then you will get the point. Apply averaging filter, so you just apply averaging filter 1/9 throughout this 3x3 image. Averaging filter 1/9. Okay, so that's all. If you're not satisfied with the marking, you compare with your friends. Bring your friends, then I will refer to the lowest marks. So in other words, don't compare. Okay, that's all. I would like to go to the slide. So we are still at chapter 4. Now is already half of the semester. So we are going to have another half of the semester. Hopefully we can finish all the another three chapters until chapter 7. A few assessment, final examination, and also the project assignments. Okay, right. So let's open the slide. I'm not mistaken, we are still at chapter 4. Chapter 4, image segmentation. Okay, let me share this slide first. Okay. Okay, digital image processing, image segmentation. We are at the chapter 4, which is a color. So this is detecting cell using segmentation. Detecting cell. This is an example of image segmentation. If I'm not mistaken, I've shown to you last time how we can perform a segmentation by using a software, especially MATLAB. We can easily find the apps in the MATLAB where we can do a segmentation based on color. So now you can also see at this MATLAB demo in the MATLAB software, the segmentation of detecting cell using a segmentation. So what is image segmentation? Image segmentation involves converting an image into a collection of regions of pixels that are represented by a mask or a label image. By dividing an image into segments, you can process only the important segments of the object instead of processing the entire image. So this is the importance of image segmentation, where when we perform image segmentation, we will get the right region of interest. So we can process only the important segments of the image instead of processing the entire image. So far, we have been considering image processing techniques use a transform image of image. Today, we will begin looking at the automatic image analysis by examining the thorny issue of image segmentation. Segmentation problem finding. Okay, just forget it about this slide. What is segmentation? A method in which a digital image is broken down into various subgroups called image segment. So if you look at this one, this image, what is this? This human. So in order to detect the human, it is good if we perform image segmentation. Why? Because we don't want to process the image, the background image consists of tree or any object. Our interest is only human. That's why we need to do segmentation, because when we perform a segmentation, we remove all the background. So we just process the region or the segment that we interest. So we are not process all the image. That's why when we do image segmentation, we get like this. Then when we want to detect the human, then we go back to the original image. Then we perform some detection. Then we get the only human here. All right, but this is to show to you that the importance of image segmentation, where we don't have to process all the image, all the image, all the unwanted image, right? So this is the difference between segmentation and detection. Detection, we detect the object. This is dog. That, but when we do segment, we just segment. You can see the difference, right? Detection, we detect that, but segment, we segment the area of the object. So that is the difference between object detection and image segmentation. So this is another example of image segmentation. Segmentation attempts to partition the pixel of an image into groups that strongly correlate within the object in an image. That strongly correlate with the object in the image. This is the important explanation. How we can perform a segmentation, because the correlation of the object in an image. Typically, the first step in any automated computer vision application. Why image segmentation matters? Why it is important? Several algorithms and techniques for image segmentation have been developed over the years using domain-specific knowledge to effectively solve segmentation problem in that specific application area. This application include medical image automated, driving video surveillance, and machine vision. So during medical diagnosis for cancer, pathologists stain body tissues with hematoxylin and eosin HNE to distinguish between tissue types. Then they then use an image segmentation technique called clustering to identify those tissue types in their image. Clustering is a method to separate groups of objects in a scene. The K-means clustering algorithm finds separation such that objects within each cluster are as close to each other as possible and as far from the object in other cluster as possible. So this is the example of segmentation. In medical, it is very important to assist a doctor. All right. So we can use clustering to distinguish between tissue types. Bottom image, in an image of body issue with stained with hematoxylin and HNE. So doctor will need this final image, because they can make a decision on the diagnosis. So this is all image processing done by image segmentation or clustering, image clustering. For the autonomous driving, for example, when designing a perception for autonomous vehicle, semantic segmentation is popular used to help the system identify and locate vehicle and other object on the road. So there are a lot of methods for the segmentation, but in this class, I'm not, I don't have intention to uh, explain the method, but you only need to understand the concept, because sometimes all the methods is available in a programming language for image processing. So you can just easily use it, but the most important, you understand how to use it and the conceptual behind the image segmentation. If you go to the MATLAB, for example, you can use apps. I think I already showed to you last time the image application, image segmenter apps based on color threshold. So this is the example. Segmentation attempts to partition the pixel of an image into groups that strongly correlate with the objects in an image, typically the first step in any automated system. So this is a segmentation example, right? If you look at this one, it's blur. When you perform segmentation, okay, you can get the object. You can count the object easily based on this segmentation. So let's look at one method, very simple method for image segmentation. It is gray level discontinuous that we tend to look for in the image: points, line, and edge. We focus on only a point with the points. Let's see what is the meaning of the point detection. This is also one of the segmentation. When we perform this point detection, we actually detect the point. We do a segmentation of point based on point. So this is how the mask of point detection looks like. Okay, this is 8, -1, -1. Points are detected at those pixels in the subsequent filtered image that are above a set threshold. If you have this X-ray image of a turbine blade, we perform the point detection. We can and then after that we perform a result of thresholding. We can get this defect of the X-ray turbine, or we are actually perform some image segmentation, and then finally we detect this point where it is the defect of turbine blade. So for the line detection, this is the mask of the line detection: horizontal, 45, vertical, and also negative 45. This is used for, this is an example for the line detection. Wire bond mask. If you want to detect any defect of the wire bond, then we can perform a line detection, either -45, 90, straight line, 45 degrees, 360 degrees. It depends on what type of line you want to detect. Okay, so this is like for the edge detection. Line, okay, the same thing. Oh, sorry. Edge detection. This is the theory about the edge detection, but I don't want to go to the detail of this edge detection. Okay, there are a lot of method for the image segmentation. Okay, this one I would like to. This is like this is the in test one, question in test one, fingerprint, if I'm not mistaken. Fingerprint, let me see. Oh no, this is not the fingerprint. In test is a rice, rice image, but this one is a fingerprint. This is the example of image segmentation by histogram. If you look at this grayscale image, then when we plot, we have to obvious frequency of grayscale value, and then when you see the image, then easily you can spot the low level is the print, the thumbprint, and the high pixel value is grayscale. It's grayscale. So if you want to perform image segmentation easily, you can just cut this histogram, then remove it out the background and change the value into white, and then you get this one, right? If we compare to the original one, you have a grayscale background. All right. But when you perform histogram segmentation, you already remove the background. Now your background is turned to white, except that got a few noises here lah. So in order to perform that, you can go to the MATLAB. This is the example of histogram, where you can run this coding in order to get to do the image segmentation. Okay, so this is another method. Okay, this is the example of rice. You see, you have a lot of pixel value at low level, because you see you can see the black background here, right? Then we can perform a segmentation based on the image histogram of rice. Okay, so that's it. The chapter 4 on the image segmentation. You the slide that I just keep, it is not important for the final examination. The slide that I explained, please try to understand it for your knowledge, because that is the basic concept of image segmentation and also color image segmentation. If you understand the concept, then it is easy for you to explore the coding, because the coding you can just easily get it from the internet, from the website resources. Okay, that's all for today's class. Thank you very much. Hope I can do the physical class next week, and we will see, and I will inform to you in the group whether we can have a physical class or not. Thank you very much. See you again. Assalamualaikum. Bye bye.